joining me. We're going to learn another derivative rule called the chain rule. So we've looked at products of functions and differentiating those. We've also looked at differentiating quotients of functions. But very frequently, what we actually have is an embedding of one function inside another. So for instance, it may look something like this. We have a composition of functions where the g function is located inside an outermost function. And this is what we want to be able to take the derivative of. The way we do that is we find the derivative of the function f, but we remember that the g function was embedded in f, so it is still embedded in its derivative. However, because the embedded function also has a derivative, we're going to multiply by the derivative of g. So let me give you two examples of this. The first example is, let's suppose f of x is equal to 3x minus 1 to the 10th power. Now here clearly we have an embedded function. The embedded function is the 3x minus 1. The outermost function is raising to the 10th power. So when you're dealing with the chain rule, you need to be able to identify your innermost function and your outermost function, because that kind of tells you where to start. Since the outermost function is something being raised to the 10th power, I'm going to use the power rule to start off with. So the derivative here, I'm going to start by using the power rule. The power becomes a constant multiplier, and I decrease the power by 1. Now you'll notice that the function that was embedded previously is still the embedded function. I didn't change the embedded function. A common mistake is to put the derivative in here where the function was embedded previously, but we don't want to make that mistake. The same function that was embedded before taking the derivative is also the embedded function after taking the derivative. However, the chain rule comes along and it says we also need to multiply by the derivative of the embedded function. So here I need to multiply by the derivative of this 3x minus 1. The derivative of 3x minus 1 is 3. So combining my constant multipliers, I get 30 times 3x minus 1 to the 9th power. Let's do one more example. Let's suppose f of x now equals 14 times sine of 2x squared minus 4. So now when I take the derivative, I need to ask myself, what is the embedded function and what is the outermost function? Here, the embedded function is the 2x minus 4. The outermost function is the sine function. Therefore, when I begin taking the derivative, the first thing I'm going to take the derivative of is going to be my sine function. Since I have a constant multiplier, it becomes part of my derivative, and the derivative of the sine function is the cosine function. The chain rule now kicks in, and it says you need to multiply by the derivative of the embedded function. Since the embedded function was 2x squared minus 4, I'm going to multiply by the derivative of 2x squared minus 4. The derivative of 2x squared minus 4 is 4x. So here I have a 4x times a 14, which gives me a 56x times cosine of 2x squared minus 4. Notice that at the end, the embedded function that I started off with is still the same embedded function. Thank you very much for joining me today, and remember, if you're not having fun, you're not doing it right.